Hi everyone and welcome to the Column Cymru revision sessions. The session this evening will focus on basic differentiation for additional maths level 2 and will be presented by Mr. Tinkler from a school in Newport. The session will last around 45 minutes where Mr. Tinkler will run through the relevant content. If you have any questions during the session, please use the Q&A section and we will do our best to answer your questions. You will see that there's a hyperlink in the Q&A section. If you're happy to leave your name and email address, we would love to keep in touch with you so we can send you information about future events. You can click on the link at any time during the session. Today's session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Column Cymru tab. Thank you, Mr. Tinkler. Over to you.
Evening and welcome to the second session, and it says it's on basic differentiation. Now there's 2 or 3 different styles of questions that you get with differentiation, and I'll try and show you those today. So first of all, what is differentiation? The gradient of a curve equals the gradient of the tangent at that point. And I've got a picture to show you what I mean by there. The tangent, which again is a term you should be familiar from numeracy and GCSE maths, T for tangent, T for touch. So the tangent just touches the curve. And you can see this curve, hopefully this part, you can see the curve has got a negative gradient. Whereas this part, we have a positive gradient because it's going uphill. So the gradient of the tangent will change depends where we're asking on the curve. If we're asking here, it'd be a negative gradient. If we're asking here, it'd be a positive gradient. If we're actually asking here, it would be 0 because it's a flat line along the bottom. But for this part, we're actually asking for the tangent at 2, 4. So we're told the curve is y equals x squared. Previously, you will have drawn in maths and numeracy a triangle to tell you the gradient. And the gradient is the change in y, which is 12, over the change in x, which is 3. 12 over 3 is 4. And that's what you've been shown before. But for additional maths and A level, there's a more precise strategy. So as it says, the bottom, the gradient of the curve at 2, 4 is 4, and it's different in different places. So here's your upper level thinking now called differentiation. Now, differentiation is a word that's used in lots of different contexts, in lots of different subjects, in lots of different genres around the world. But for A level maths and additional maths, differentiation is known as dy dx. Dy dx tells us the gradient at any point on a curve, but we have to choose which point. It's used to find a general expression for the gradient of a curve at any point. The general expression is known as the derivative and can be found in 2 different ways. Differentiation from first principles and the differentiation rule. We will not be doing differentiation from first principles. That's a totally different question. Again, that is on the additional maths paper. Lots of different ways of doing that. Today we're looking at differentiation rule. Now, if you're doing additional maths, you might have been told something about like this. If y equals kx to the power of n, then the derivative or the differential, you multiply by the power, so the n is coming in front, and the power goes down by 1. D for differentiate, D for decrease. But here we go. Multiply by the power, divide by the new power. Differential of a constant, e.g. plus 7 equals 0. Now I've just realized that's a mistake. Multiplied by the power is correct. New power decreases by 1. Okay, the power decreases by 1, and that's what it's explaining here. And again, when we get to the questions, that's when it's more useful to see when it's in action. Differential of a constant, e.g. plus 7, will go to 0. Why is that? Because if I draw the line y equals 7, which I've just drawn at the bottom of the page now, you will see in theory it is horizontal, and a horizontal line, the gradient is worth 0. So that's why it gives you the 0 there. Okay, so here's some basic sort of examples where we're bringing the idea. So the first answer, you multiply by the power, 2 7s are 14, and the power decreases by 1. So that would give us 14x. Some people write 14x to the power of 1. Most people write 14x. Next one, 7 8s are 56. 56, you should write your answer with dy dx in the front. 7 8s are 56. You multiply it by the power and the power decreases by 1, goes to 56x to the power of 6. The next one, I'll just read out some of these answers, is minus 36x to the power of 3, 9 fours. Next one is minus 24x to the power of 5. Okay, this next one here is a little bit different. This would give us minus, and I would have to write dy dx in front, but minus 20x to the power. And the classic mistake people think, when you decrease minus 4, it does not decrease to minus 3, it decreases to minus 5. It goes down from minus 4 to minus 5. Why don't you have a think of yourself with this next one now, the y equals 12x minus 5, before I tell you the answer. Okay, that answer would be, I'll say dy dx should be in the front, minus 60x below minus 5, down from minus 5 is minus 6. Last two, a little bit different. So we've got two minus signs here. That would give us 24x. 8 threes are 24. Minus times a minus makes it a plus. Minus 3 below minus 3, down from minus 3 is minus 4. Again, why don't you have a think of the last one before I move on? Minus 9 times minus 1 would actually make it 9x, and the power decreases by 1 to the minus 10. Now, differentiation with a fraction, and most of the questions you'll see coming up will have one with a fraction. You're not allowed to differentiate, or in fact integrate, which is session 4, when x is on the bottom. Now, you might have seen this idea in maths. When x is on the bottom, you have to take it to the top, and that will make it minus 2. Now, that is not the question. I've still not differentiated yet, but I've had to go y equals x minus 2. You're not allowed to differentiate when it's on the bottom, only when it's on the top. So you can see now it's appeared y equals x minus 2. Now we can differentiate a bit like the others. That goes to minus 2x multiplied by the power. In theory, there's an invisible 1 in the front, so it goes to minus 2x to the minus 3, and so on. Now the next one's the same, so nothing major there. The next one, number 3 on my slide, you leave the 2 on the top, so you write 2x to the minus 3. I'll put that answer up. 2 times minus 3 is minus 6. Decrease minus 3 by 1 to minus 4. Why don't you have a try at question number 4 yourself? This is all leading to the past paper questions. Okay. So minus 5 times 6 is minus 30. Decrease the power by 1, or power goes down by 1 to minus 6. Now last one, I apologize, it doesn't quite fit perfect on the slide. Minus 7x to minus 4. Just be careful, 2 minuses will multiply to make a plus. 28x to minus 5. Now, is a calculator paper the additional maths? And in fact, when you do A level, that will be a calculator as well. So there's no problem with checking things like that. If you're not confident with your minus signs, we all make mistakes with negative signs. And as it says at the bottom, you must ensure your expression is written in index form, as in with a power. Now, these ones, again, you might have seen this in GCSE maths. You might know that 25 to the power of a half is the same as square root. Cube root is the same as the power of a third. The last one's a little bit specialist. So the first one, I've rewritten square root. As it said, we need an index form, y equals x to the power of a half. Dy dx, half in front. Half times 1 is a half. Power decreases by 1, goes to from half to minus a half. Now the next one, cube root, is the same as x to the power of a third. This causes some problems. I will put the answer up and then I'll explain what the problem is. A lot of people write 1/3 in the front and then think it's x to the minus 1/3 because the half goes to minus half. It's not. If you've got a third, take away a whole one and give you minus 2/3. On additional maths, you have so much time on each of these exams. I would advise you to use your calculator if you're sure by doing 1/3 take away 1. Now, next one's a little bit of a trick question. The square root of any number squared goes back to the original number. So it goes to y equals x. And the differential of x is worth 1. Well, last week's topic, we spoke about gradients. If that said 7x, the gradient of the line 7x is 7. The gradient of the line x with an imaginary 1 in front of it is just 1. This explains why it goes to that. You do 1x to the power of 0, but anything to the power of 0 is worth 1. You won't see ones like that in additional maths exams. Well, you shouldn't do. I've never seen one like it so far. So, we also have questions on this topic that talk about second derivative. d2y dx squared is how it's said. And all we do is differentiate our first answer from dy dx. And we'll find out more about that in this session, but you'll find out more about that in next week's session with stationary points. It's used a lot there. So here's some first questions. So it says past paper question 1. I think I've got 14 today, but lots of them got parts A, B's and C's, and there's 2 or 3 different styles. So I will stop for a minute and see if you want to write those out and put any answers in, and then I will show my solutions. There's 3 terms and there's 3 marks you'll see on the side. 1 mark for each term. I'll just quickly put the answers up. I'm not saying anyone would have seen them, but just to show to you I have got my answers ready, and then you can think if there's any questions you want to ask on the back of those. Okay, the first one, where did I get that from? Well, 8 sevens are 56. Power decreases by 1. 2x differentiates to 2. Why is that? Well, let's show you over here. 2x, that really has a power of 1. 2 times 1 is 2. X to the power decrease makes it the power of 0. And hopefully you're familiar from maths. Anything to the power of 0 is worth 1. So it's 2 times 1, which equals 2. But if I ask any question that says 7x minus 3x, 4x, it will just be the coefficient in front of the x. Minus 23, the line minus 23 is horizontal, so the gradient is 0. Some people do write plus or minus 0 on the end. I don't, but if you've written plus or minus, that's fine. You won't be penalised. Now, the next question, 3b, we've seen some examples like that already today. I'll write that answer up. Minus 8x. Minus 8x to the minus 9 multiplied by the power. There's in fact like an imaginary 1 in the front, so 1 times minus 8 is minus 8. And then you multiply it to make minus 8, and then you decrease the power again by 1, making minus 9. Okay, the last one, again, people don't seem to like when there's fractions. So again, there's like an imaginary 1 in the front. 1 times 3 over 2 is 3 over 2. Then it's x, and then what happens with the power? If in doubt, do 3 over 2, take away 1 on your calculators, but that will give you the power of a half. Now, some people might put the power of 0.5. That is fine, but fractions are more precise. So if you get fractions like a third. So there's all those 3 answers. Give you a second to see if you want to ask anything or write any questions or any of that down before I move on to past paper question 2. Okay, I'm now moving on. Now here's a different style of question. I did say you'd see a couple of different styles today. dy dx equals 135 when x equals 3. So we're going to have to differentiate this bit here. And the differential of y goes automatically to dy dx. I've not shown you a question yet with the letter in front, but if that a didn't exist, I'd bring the 3 in front of it. So 3ax, the power still decreases by 1. So if you decrease 3, it goes down to 2. And here it says dy dx equals 135. So next line, I'd write 135 equals 3. I still don't know what a is, because that's what I'm trying to find. The question says find a constant a, 3a, but I now know that x equals 3. So I'm going to substitute that in there. So the top line is additional maths. The second line is GCSE, really substituting in. So here's my answer now. dy dx equals 3x ax squared. Let's get rid of all this rest so you can see my answer clearly. And then I've shown subbing in 135 divided by 27, a equals 5, which again always feels nice when you get a nice round answer in these sorts of questions. Next one. Now we're back to the first style. So I'm going to stop and ask you if you'd like to work through these. Part B we didn't see before, but we saw it on our ordinary PowerPoint slides. So I'll give you a couple of minutes. 5 marks is worth about 8 or 9, 10 minutes of work, but it won't take you that long. I'll give you a bit of time before I put some answers up. Okay, the first answer is appearing now. Second answer, multiplied by the power, and the power decreases by 1. Now, next one, 5/2, subtract 1 from the power, decrease the power, goes from 5/2 to 3/2, 5 halves, take away 1 is 3/2, and again, if in doubt, use your calculator. So next question's appearing, find d2y dx squared. Now I'm going to show you how to do the top one, which is question 8 from a paper. They're not always in the same place in the papers, but often they're very similar. If you're familiar with the past papers, and they're all available online. The questions, most of the time, 15 out of the 18, generally the same topics most years. 2 or 3 are a little bit different, and that's how it should be. So my first answer here, first of all, before I do d2y dx squared, I've got to differentiate this bit. I've differentiated 24x cubed, 4 6s are 24, decrease the power by 1. Same with the 4x line, that decreases from x to the power 1 to x to 0. Now on my answer here, I've written dy dx, but I really mean d2y dx squared. I wouldn't be penalised for that notation, but I want to make sure you know that how it should be written. And where did I get that from? 3 24s are 72, decrease the power by 1. The differential of 4, again, the line 4 is horizontal, and the gradient of the line 4 would then be 0. So why don't you have a try of 7a, which is a little bit easier. Okay, here's my answer. I'm glad I did the notation properly this time. d2y dx squared. 6 9s are 54, subtract 1 makes the power of 8. 8 54s, I'm sure lots of you could do that in your head, but use your calculator. And to take away the power, deduce the power by 1, deduct the power by 1, anything that begins with a D, decrease. And you'll see this is 2 marks. You get 1 mark for each of the lines. You get 1 mark for that line and 1 mark for that line. 2 marks is 3 minutes. I will not take you 3 minutes. Now, next slide. Back to now. The reason why I've got more slides on this type than any others, because that's a more common question. So again, have a go at that question yourself. Give you a few minutes. Part C is pretty samey. If in doubt, use your calculator. Okay, and here's some of my answers. Now, it'd be a good idea if you had a look through all those first before I explain each of them, where they came from. Okay, so 7 5s are 35. Deduct 1 from the power, decrease the power, minus 5x. We've seen now anything with x in front of it, you just lose the x because it would go to x power 0. Minus 2 disappears because that gradient is worth 0. Next one, minus 6x, decrease minus 6 goes to minus 7. Last one's a little bit different. 3/5 in front. If you do 3/5, take away 1 on your calculator, it will give you minus 2/5. Next slide. Again, same idea, just part B is a little bit different. Again, I'll give you a few minutes to do that, and hopefully you can think your previous answers will help you. Okay, and the answers will appear in 10 seconds. Just letting you have. Right, those are the answers. Again, I suggest you have a little look through before I explain them. Give yourself a chance to understand. Okay, where did these come from? Well, 6 5s are 30. Power decreases by 1. 7x goes to 7. Minus 2 disappears. The next one, you'll notice I've done a little bit of work before I could differentiate. I've had to take the x power 6 upstairs and I put a minus in front. I've never seen a question where it started with a minus on the bottom. If it did, or on the denominator, if it did, you would change it to a positive at the top, but I've never seen one like that. Minus 6x decrease by 1 goes to minus 7. And the last one, I know it doesn't show greatly on here, but it is 5 over 2. 5 over 2, x, take away 1 from the power, gives you 3 over 2. Those questions you will definitely see when you do an exam on this. Now, next two very straightforward questions. So 4 marks should equate to about 7 or 8 minutes. I'll give you 2 or 3 minutes before I put the answers up. If you're unsure, you differentiate. First of all, 2x6 plus 3x, you differentiate that. There's my first answer. 2 times 6 is 12. Decrease the power by 1. 3x differentiates straight away to just 3. Because the gradient of the line 3x is 3. From you might know from year 11 maths, y equals mx plus c. that these questions aren't always in the same place. The top one's on 12 and the second one's on 8. Why have I not put part B on? They might have been integration questions, which is topic 4. 8 is worth the same marks as 12, even though it's slightly easier. There's my 2 lines in one go. I got 2 marks. I got first mark for writing 20x to the power of 9. Second one, 9 20s, 180. This is pretty straightforward, and these are the basic skills you'll need if you plan to do A-level maths as well. So next question. Now this one is the other style. You don't get these every year, but these are on most years. So given the following facts, find the values of A, B, and C. All they've told us so far is that y equals. But as soon as they mention d2y dx squared in this sort of questions, or some of them just say dy dx, I would straight away go and differentiate y equals. So I'm going to go and do some work off here. I don't really know why I'm doing this yet, but I've seen it says d2y dx squared. I can't jump straight from y to d2y dx squared, so I'm going to differentiate y. Now again, this a is a bit of a problem, but if it just said x to the power of 5, I'd write 5 in front, and then I have ax to the power of 4. Differential of 7x earlier was 7, so the differential of bx is plus b. And the differential of c is like a constant, so that says like a plus 7 goes to 0. But it does tell me about d2y dx squared, so I'm going to go and write d2y dx squared. And I'm going to differentiate this. Well, 5 4s are 20. I've still got the a in front, 20ax cubed, and the differential of b would disappear. So now I'm going to compare 20x cubed with 20ax cubed. And that tells me that a equals 1. Now, I wouldn't have written out like that. I'll show you how I wrote it out in a few seconds. When x equals 0, y equals 5, I'm now going to substitute those into here. When x equals 0, y equals 5. So I've got 5 equals, well, x is 0, 0 plus 0 plus c. That makes c worth 5. When x equals 1, y equals 9. So instead of y on the front, I'm going to write 9. X equals 1. 1 to the power of 5 is 1. 9 equals a, plus b times 1 is b, plus c. But luckily, we already know from earlier that a is worth 1. So I've got 9 equals 1 plus b plus 5 that I got from here, that c equals 5. So I now got 9 equals b plus 6. That makes b equals 3. I have another question if you like that later that I'll give you more chance to practice yourself. And now I'm going to rub all that writing off so I can show you how I laid out my solution for 4 marks. So my answer has appeared. I'm just rubbing that out the way. So first of all, you can see in my solutions, I start with dy dx equaled, did the same thing, d2y dx squared, I got a equals 1. Sometimes though, and in this question in particular, I could have started by using these 2 lines, which is what I actually did do. I used x equals 0 straight away there, and I found out c was 5. It doesn't matter which order you do them in. If you find it's not working in the one order, you change it to the other order. Okay, so I got my d2y dx squared from that, but I realized straight away that if x was 0, y was 5, I knew c was 5 straight away without too much thinking. Then I used this bit over here, but that obviously relied on me having the a was 1 from earlier. Doesn't matter which order you work them out, doesn't have to be in alphabetical. So next question, back to a regular style, because you get these on every single paper. Couple of minutes to do this. Now, there's nothing you've not seen before in these questions. So in about 10 seconds, I'll put my answers up for you to check. Okay, and here's my answers. Don't think there's anything particularly different here, so I'll just run through. 9 4s are 36, power decreases by 1. 2 4s are 8, power decreases by 1. You can put a power of 1 there, but we've never really done that at GCSE. And -3 disappears. I think we've even seen this question before today. -8 in front, power decreases by 1. And again, just be careful with the fractions. 3/4 goes in front, 3/4 take away 1 will give you -1/4. Now, on this next slide, classic easy d2y dx squared. So I will leave you to work on that for a few minutes. Okay, first of all, here's my answers to the 12A one on the top. There is a calculator paper, but I'm sure most people will be able to do 21 times 6 in their head, but you have so much time on these papers, take your time and get them right. Just remind you, differential of 4 disappears. So if you want to know, I had 1 mark for that, and I had 1 mark for that. Bottom one's even easier. 3/20 are 60, decrease the power by 1. Even I probably use 60 times 19, probably use my calculator check. It was 1,140, not a number I'm used to writing often in school. X to the power of 18. So those ones are short and sharp, and they're on every year. And as I say, you will see them again in session 3 on stationary points. So that's why I've done basic differentiation this week. Now, the next one, there's 4 questions on that. Yeah, I'm used to normally only seeing 3. So work your way through those. Part B does say x to the power of -12. May not show up brilliantly on your screen. On my screen says x to the power of -12. So I'll give you a few minutes on that before I put some answers up. There's 3 or 4 more questions to go, where I've got another one in the trickiest style. Okay, so I'll put some answers up now. Don't think there's anything different here. Part C and D are a little bit awkward. Nothing on part A, I believe. -5x goes to -5, 22 disappears. As I say, that did say -12. So remember, it's -12 to -13. 3/8 take away 1 gives us -5/8. And you're not allowed to differentiate when x on the bottom, so you bring it up to the top. -4x. Just make sure you remember to put -5, not -3. Okay. Now here's another one of these awkward style ones. So I'm going to give you a little bit longer, 3 or 4 minutes. It's only worth 3 marks. It's not the hardest one. See if you can work out A, B, and C. It's worth less marks because there's less lines to do. Once you're working through this, I just say if A had been 5, you would have said 4 5s are 20x cubed. Well, it's not worth 5, it's worth A, so you say 4a x cubed. That's a little bit different. Seen a couple of those today. I'll leave you to work on that for a bit longer. Okay, so you see my answer appear there. Sorry, I forgot to tell you I was going to put the answer up. So what I do, first of all, I did dy dx. I've done dy dx, 4ax cubed plus 3bx squared. The c would disappear. It's just like a number. A whole number. Could be a decimal, could be negative, but any number without an x on the gradient is worth 0. Then I compared my line with the line in the question. It told me that 12x cubed, and I've got 4ax cubed. So I knew that 4a must be worth 12. I show that by underlining 4a must be worth 12. So if 4a equals 12, a equals 3. Same with the other one, 3b equals 6, because the x squared, whoops, the x squared lines up with the x squared. 3b equals 6, so a equals 3, b equals 2. Where do I get c equals minus 6 from? Well, again, I start with this one because I thought it was the easiest mark. X equals 0, y equals minus 6. So I put minus 6, 0 to the power of 4 is 0, another 0 plus c equals minus 6. And that's how I would have laid my solution down. I obviously wouldn't have done the arrow. Next question, 10a, very straightforward, 10b, another one of these slightly harder questions to do. Give you time to work those out before putting any answers up. Okay, I'll put the answer up for part A because that's pretty straightforward. So if I was you for part B, first of all, I would differentiate this. Differentiate the line y equals. Then compare coefficients is what you really call it. So 3ax squared plus 2bx plus c plus 0. And it's not plus d. That's where people often make mistakes. And generally, you get a mark for differentiating that properly. Then compare coefficients. Now, my answers appear for a few seconds. I'll write them back up in about 30 seconds for you to compare what letters you got. I've never seen these be decimals. I suppose you could get a 0.5, but I'd be surprised if you ever got 3.2764 recurring, something like that. I think I'd gone wrong. This one, unfortunately, is when x equals 1 rather than x equals 0, but it still makes it quite easy. I'm sure you all know how to sub in. So here's my answer now. Let me explain what I did. I differentiated 3ax squared plus 2bx plus c, and then I compared them with the line up above. And you'll notice I've already underlined in colour this time. 3a has got to be worth 12 because they line up together. The coefficient of x squared is 3a. On this one, the coefficient is 12, so a equals 4. Same on the yellow bit. 2bx compares with the 4x. 2b equals 4, so b equals 2. The number on the end says 1, and we just found we had c, so c is 1. So the a, b, and c all came from differentiating. The d, however, came from something else. There was no d here, so we couldn't get anything with d. X equals 1, subbed it into the top. I had 1a, 1b, 1c, but I now know what a, b, and c are worth. So I substitute those in, and I found the answer d equals 3. Not that difficult. And so if you download all the past papers and you use all the past papers that are available on the website, you'll find that type of question, not in every paper, but in a lot of them. Now, that's the final question for today's session. I'm sure if there was any questions, you can put them on the Q&A tab. But that's it for this week. Thank you very much for listening. Hopefully you found it useful.